Algebraic fractions. Well, first of all, an algebraic fraction is a fraction with variables. So to add an algebraic fraction, by the way, it's going to be the same rules as adding fractions with numbers. So let's go ahead and remind yourself how to do one of those. So how do we add 1/2 plus 3/10? Well, the denominators are not the same, and we've learned that you cannot add fractions with unlike denominators. Just like you cannot add a variable or an algebraic expression with unlike terms. So what we're going to do is step 1, get an LCD, which is the least common denominator. So in this case, the LCD is 10, because you could say 20. 20 is a common denominator, but 10 is called the least common denominator. So what I would like to do is build each fraction to have a denominator of 10. And then what I noticed, if I multiply top and bottom by 5, because we learned if you multiply top and bottom of a fraction by the same number, it doesn't change the fraction. So like in this case, 1/2 is the same as 5/10. And I'm going to leave the second fraction alone because it already has that 10 in the denominator, and I'm going to add these up. So that's step 3, add the numerators, right? 5/10 plus 3/10 is 8/10. And there is a fourth step that I forgot, is reduce it if possible, because 8/10 can be reduced. 2 goes into both of those. So like this is 2 times 4, and this one's 2 times 5. So we can see we can cancel the 2's and say that that's the same as 4/5, just as you can divide both sides by 2, top and bottom, and it ends up being the same fraction. So that would be the answer. Okay, so let's do it with variables. Same process. But now the LCD, right, just like before, the LCD is an x cubed. That would be a little too high. I'm going to go for x squared, because it's going to be each base, but with the highest exponent. I'll talk about that a little bit more in the next example, but let's just write an x squared for now, for each denominator. And if we can see here on the first expression, if we multiply top and bottom by x, that would make the denominator x squared. So now that the denominators are both x squared, what we're going to do is do step 3, add the numerators. They're not like terms, so we just leave it like that and leave the denominators alone. Okay, let's do an example more complicated. Okay, so what if you had this third example? The LCD between the numbers is 4. But the variables, it's each base with the highest exponent. So the LCD in this case would be a 4, and since x squared is larger than x, I'm going to use the x squared, and since y cubed is larger than y, I'm going to use the y cubed. I'm not going to add them together. I just take each base with the highest exponent. So let's go ahead and do that. So the first one, we don't need to multiply anything on the number or the x's. It's only the y, and we need to multiply this by y squared to get a y cubed. So I'm going to multiply top and bottom by y squared, and we'll get a 5y squared for that first fraction. On the x's, we need to multiply a 2, because 2 times 2 is 4. And then the x, we need to multiply one more x to get an x squared. The y cubed we're already good with, so that would be a 14x. So that is step 2, building each fraction to have like denominators. Step 3, we're now going to add them, the numerators, and leave the denominator alone. Again, these are not like, so we just leave it, and that would be the answer. Okay, what if you had 2 terms in the bottom, in the denominator? So let's do one last example. When you have more than one term, the whole term has to be the same. Because, for instance, what if x is 5? The left denominator would be a 7, and the right would be a 2, and they have nothing in common. So the LCD in this case is 1 factor of e. So let's go ahead and do that. On the first fraction, to get each denominator to be the same, we need to multiply top and bottom by x minus 3. Again, because each one of these are just so different. So that would be a 4x minus 12. On the second, it's missing. We need to multiply this by x plus 2 because it's missing an x plus 2 top and bottom. So this would just be an x plus 2. Now we can do the last step, add the numerators and then leave the denominator alone. So what would that be? Is 5x minus 10. And that would be the answer. Now you do have to realize that these could reduce. We could factor out a 5, but we get an x minus 2, which is not the denominator. No, factor in the denominator is an x minus 2. So it cannot be reduced even if we tried. That is how we add algebraic fractions.